Hello and welcome back. In this tutorial video, we're going to be taking a look at the homework solutions to Unit 5, Lesson 6 on the final work with quadratic functions. Let's begin. In question 1, we are asked to solve each of the following equations using the method described. Place your answer in the form asked for. So if it says answers are exact, we're going to write our answers as a whole number or a rational number if it comes out to be that way, or a square root. If it says round to the nearest tenth, that means you put it in your calculator and you have a decimal approximation. Okay, let's begin. Solve by factoring. Well, first thing you have to remember to do is you have to remember that to solve a quadratic, quadratics must be in standard form. What is standard form again? ax squared plus bx plus c equals 0. Where a is the term in front of x squared, b is the term in front of x, and c is the term by itself. You have to be able to identify a, b, and c for completing the square methods and quadratic formula. And factoring, really. You have to identify it all the time. First things first, let's get these numbers in proper form. So for part A and B, I'm actually going to start this by putting these in proper form. So to do that, I'm going to be subtracting 4x and subtracting 1, and that leaves 0 over on the right-hand side of the equation. This now becomes 2x squared minus 2 minus 4 would be minus 6x, and then plus 0. So in other words, there's nothing there, equals 0. Now, to continue, I could divide by the 2 to kind of reduce this equation down a little bit more. And that would be x squared minus 3x equals 0. But at the end of the day, I'm still going to need to factor it. So prime factorize this thing. This would be x times x minus 3 times x equals 0. Now you guys can see that the greatest common factor of both terms would be x. So I'm going to pull that x out. What's left over? Well, what's left over is highlighted in black, x minus 3. And that's equal to 0. We're going to use, anytime you factor, you're going to use the zero product property to solve it. That means you set each factor equal to 0. X equal to 0 is one factor, one answer. Or x minus 3 equals 0. In which case, in this, you have to add 3 to both sides to get a solution. So x equals 0 and x equals 3 are our two solutions for part A. Part B, again, we're going to solve by factoring. I'm going to move everything on the right-hand side so I can make the right-hand side equal 0. Cancels, 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 all 0 on the right-hand side. What am I left with? Well, 2x squared minus x squared would just be x squared. 5 minus 9 is negative 4x. And 3 minus 15 would be negative 12. That's equal to 0. Well, let's try factoring it. We'll use the cross. A times c goes on top, b goes on bottom. A is 1, c is negative 12. So a times c would be negative 12. 1 times negative 12 is negative 12. And b would be negative 4. Now I need two numbers that multiply to give me negative 12 and add to give me negative 4. Those numbers would, of course, be 6 and 2, specifically negative 6 and positive 2, as they add up to negative 4. I'm just going to slap on a variable in front right here, and there's my factor. X minus 6 times x plus 2 equals 0. Remember, it was originally equal to 0. Again, I'm going to use the zero product property, which means x minus 6 equals 0. That's the first factor. Or x plus 2 equals 0. And the first solution is x equals 6. The second solution is x equals negative 2. Let's go ahead and write this in standard form, and then we're going to complete the square. So let's go ahead and move everything from the right to the left. Cancels, cancels. We get x squared. 10x minus 2x would be plus 8x. 2 minus 5 would be negative 3. Okay, now to complete the square on this, we have x squared plus 8x plus leave some space, leave a little more space, minus 3 equals 0. This term right here is b over 2 squared, so let's figure that out. B would be 8, so b over 2, half of 8 would be 4, square that would be 16. So we're going to add 16, but we will immediately subtract 16 from that. Let's go ahead and section that off. That becomes x plus square root of 16 is 4, quantity squared, and that's going to be equal to minus 19 equals 0. X minus 4, quantity squared. We're going to add 19 to both sides. Equals 19. We have x plus 4 equals plus or minus the square root of 19. Well, the 19 cannot simplify any lower than that, so what we're going to do is we're going to subtract 4 from both sides, and we have two possible answers. We have x is equal to negative 4 plus the square root of 19. We'll get an approximation there. Or x is equal to negative 4 minus the square root of 19. We'll get an approximation there. The first one, negative 4 plus the square root of 19, you get about so to the nearest tenth, 0.30, 0.36, 0.4. And for this one, negative 4 minus the square root of 19, we get about negative 8.4. For part D, we're going to solve this using quadratic formula, and we need simplest radical form. So a couple things, let's write the quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Since we need it in simplest radical form, we'll our list of perfect square roots: 149, 16, 25, 36, 49, 64, 81, and 100. Let's see here. I'm going to add 3x to both sides. Add 4 to both sides. And we get 2x squared plus 6x. 3x plus 3x is 6x. And then 3 minus negative 3 plus 4 would be plus 1 equals 0. Where A is 2, B is 6, C is 1. Quadratic formula begins. X equals negative b, so negative 6, plus or minus the square root of 6 squared, minus 4ac. So that would be 4 times a is 2, c is 1. All over 2 times a, which would be 2 times 2. Negative 6 plus or minus the square root of, well, 6 squared would be 36, minus 4 times 2 is 8, all over 2 times 2 is 4, which is negative 6 plus or minus the square root of 28 over 4. Break down 28. That breaks down into the square root of 4 times the square root of 7. Which we can take the square root of 4, so negative 6 plus 2 plus or minus 2 radical 7 over 4. And then we'll split this up into 2 separate fractions. So negative 6 over 4 plus or minus 2 radical 7 over 4. And when we look at this, we can divide both sides by 2, right, in both cases. And this would simplify to negative 3 halves plus or minus radical 7 over 2. Now you could write your answer like that, or negative 3 plus or minus radical 7 over 2 with just one denominator. Both representations are correct. Number 2, which of the following represents the zeros of the function? Since half of my answers are rational, half of them are irrational, I mean, I can try and factor it, but this I can see the only factors of 2 are 2 and 1, and there's no way I can get that to add up to negative 4. So this is not factorable. So I'm going to go ahead and complete the square on it. And so we have x squared minus 4x plus 2 equals 0. So x squared minus 4x plus leave some space plus 2 equals 0. And here, the third term, we're going to put b over 2 squared. So b is negative 4. Divided by 2 is negative 2. Squared, we get 4. But we have to subtract 4 also. Section that off. This trinomial here factors into x minus 2 quantity squared. That is negative 2 equals 0. Go ahead and add 2 to both sides. X minus 2 quantity squared equals 2. We're going to solve for x by taking the square root of both sides to begin with. And x minus 2 is equal to plus or minus the square root of 2. And x is equal to 2 plus or minus the square root of 2. So the square root of 2 is already in simplified form, so it turned out I didn't need my list of perfect squares. But I look at my possible answers. It's 2 plus radical 2, 2 plus square root of 2, and 2 minus square root of 2. That would be those two answers right there. The percent of popcorn kernels that will pop, P, is modeled with the following equation. P is equal to negative 0.03 t squared plus 25t minus 3600, where t is the temperature in degrees Fahrenheit. Determine the two temperatures, so two answers, to the nearest degree that will result in 0% kernels. What are we doing here, guys? We're finding zeros. Finding zeros of that function right there. So again, don't let this intimidate you. Just because it's a word problem, so what? That doesn't matter. it's still the same work. So what I'm going to do is I'm going to set that function equal to 0. So negative 0.03t squared plus 25t minus 3600 equals 0. There's my A, there's my B, there's my C. Let's use quadratic formula to do this. So t is equal to, instead of x, it's going to be t. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So t is equal to negative 25 plus or minus the square root of b, which is 25 squared, minus 4 times a times c. A would be negative 0.03. Ran out of room here. 0.03. Negative a times negative 3600. All over 2 times a, which is negative 0.03. Okay, this is kind of nasty, so let's clean this up. So 25 squared, so first we have negative 25 plus or minus, and as we begin to clean this up, we have 25 squared, which is 625. 625, and we have a minus times a minus times a minus, which is going to be a negative. We're going to be subtracting. So subtracting what? Well, 4 times 0.03 times 3600 is 432. So all of that multiplies to 432. Divide that by 2 times negative 0.03 is negative 0.06. Okay, now we'll go ahead and subtract that. And this is negative 25 plus or minus the square root of 625 minus 432 is 193. And we're going to use our calculator to write our answer to the nearest degree. So, and this is over 0.06. So t would be equal to negative 25 plus or minus about 13.89 is what you get when you take the square root of 193 all over negative 0.06. And so we'll have two possible answers. T is equal to negative 25 plus 13.89 over negative 0.06. And we'll get about 185 degrees Fahrenheit for that temperature. And negative 25 minus 13.89 over negative 0.06. That one comes out to be a little bit higher because 2 negatives is a negative minus a negative is more negative. So the number's bigger. And that turns out to be about 648 degrees Fahrenheit. Good application of solving quadratic zeros. Number 4, find the zeros of the function y equals x squared minus 4x minus 16 by completing the square. Express your answer in simple radical form. All right, the zeros. So we're going to take this, x squared minus 4x minus 16 equals 0. And we're going to complete the square on it. So x squared minus 4x, leave some space, minus 16 equals 0. What goes in here? B over 2 squared. So let's figure that out. B is negative 4. Take half of that is negative 2. Square it, we get 4. Don't forget to subtract the 4. Section that off and rewrite. This trinomial here factors into x minus 2 squared. Minus 20 equals 0. Add 20 to both sides. We get x minus 2 quantity squared equals 20. When we square root that, plus or minus square root 20, we get x minus 2 are equal to plus or minus the square root of 4 times 5. which is x minus 2, is equal to plus or minus. Now the square root of 4 is 2, so this would be 2 radical 5. Go ahead and add 2 to both sides to get x by itself. And x is equal to 2 plus or minus 2 radical 5. Number 5, explain how you can tell that the quadratic y equals x squared plus 6x plus 15 has no real zeros without graphing the function. Well, the easiest way is to evaluate, we did this in class, evaluate the discriminant. Remember, the discriminant is the term under the radical in quadratic formula, the b squared minus 4ac. If this term is positive, you have real zeros. If this term is negative, you have no zeros, no real zeros. That's how we interpret it. So the b term is 6. So we're going to evaluate that. The a term is 1 and the c term is 15. So we're going to evaluate b squared minus 4ac. Well, that's going to be 6 squared, that's 36, minus 4 times 1 times 15. So this would be 36 minus 60. 36 minus 60 is 24, or negative 24. The negative here, the negative discriminant, tells you the function has no real zeros. No solutions, no zeros. Now, in Math Course 3A, when you get to this, you'll be learning about another way to solve for quadratic functions that do not have real zeros, and that is called imaginary units. Number 6. It says use the quadratic formula to determine which of the two functions below have real zeros and which do not, then verify by graphing them on your calculator using the standard window view. Okay, so I'm not going to actually use quadratic formula. What I'm doing is I'm going to evaluate the discriminant. Evaluating the discriminant is a very quick and easy, efficient way to tell whether or not you have zeros. Okay, again, if the discriminant is positive, b squared minus 4ac is the discriminant. If your answer is positive, you have 2 real zeros. You have 2 real zeros. If your answer is negative, you have no real zeros. So let's go ahead and break this in half. A is 2, b is 3, c is negative 1. So b squared minus 4ac, in this case, would be 3 squared minus 4 times 2 times negative 1. Well, that would be 9. Negative negative is positive, so positive 8, I get positive 17. Now, who cares about the number? The number doesn't matter. What matters is it's positive. Positive discriminant, we have 2 real solutions, or 2 real zeros for that function right there. Here, b squared minus 4ac. So a is 1, b is 2, c is 3. So we're going to go 2 squared minus 4 times 1 times 3, which is 4 minus 12, which is negative 8. Again, the 8 doesn't matter. The negative does. No real zeros. Let's take a look using the graphing. Let's take a look at the solutions in our graphing calculator. In number 6, the first quadratic that we had was 2x squared plus 3x minus 1, and we got an answer of 2 real solutions because the discriminant was positive. Let's see that. 2x squared plus 3x minus 1 We're going to graph it. And as you can clearly see, the quadratic is crossing the x-axis in two locations. Therefore, it has two real solutions. The second quadratic, x squared plus 2x plus 3, was found to have no real solutions because the discriminant was negative. Sure enough, you can see how the quadratic is above the x-axis and never crosses it, therefore has no real solutions, no real zeros, or no x-intercepts.